Several of you have emailed and asked for some additional guidance on the mole ratios assignment, so I wanted to take a few minutes here just to work out an example problem here, just to kind of clarify what it is that you guys are actually doing in this assignment. I'm going to actually use the second equation that's on here, the B2O3 equation, and just walk you through that one because it has a few extra little things that we can do in here. All right, so the first thing I want you to do on all four examples is to start off with balancing the equations. So to do that, I'm going to look at my B2O3 and look over at my BF3. I'm going to put a 2 there to balance out the borons. That's going to make my fluorines a total of 6 on the product side. So I'm going to put a 3 in front of that CaF2, and then that will give me 6 fluorines on the reactant side. 3 calciums on that side, so I'm going to go ahead and balance that calcium oxide compound by putting a 3 there, which gives me 3 calciums, 3 oxygens. On the reactant side, I already have 3 oxygens. Normally we don't write the 1 there, but because we're dealing with mole ratios and I want us just to remember that the coefficients in front of the compounds are actually telling us how many moles are required, I'm going to just put that 1 in there just to make it clear. All right, now when I'm looking at this, again, we're really kind of changing up our perspective and our understanding. What this equation is telling me now that I'm looking at it is that 1 mole of B2O3 is going to react with 3 moles of CaF2. So that is what is going to be required. And if I have a 1 to 3 ratio, then I can produce a total of 2 moles of BF3 and 3 moles of CaO. So when those things are produced, when those compounds are produced, that's the maximum amount I could get if I had perfect conditions. All right, so as I'm writing out these mole ratios, there's so many different mole ratios I could write. What I asked you guys to do, I just picked some for these that were possible. So now I'm going to just write out a mole ratio. So I have moles of B2O3. I know that 1 mole of B2O3 is required. And then if I look at the coefficient in front of BF3, it's a 2. So this ratio ends up being a 1 to 2 ratio. So for every 1 mole of B2O3 I have, I will produce 2 moles of BF3, or vice versa. So in the next example, then, I'm looking at moles of CaO, and in this problem, I have 3, a coefficient of 3 in front. And then if I look at the coefficient in front of CaF2, I also have a 3. So we could say that this is a 3 to 3 mole ratio, but the reality is we can simplify that, right? So it would be a 1 to 1 mole ratio. For every 1 mole of calcium fluoride, I can produce 1 mole of calcium oxide. I can keep it as 3 to 3, that's fine. I'm just letting you guys know that you can simplify it. And in fact, on the quiz, it is simplified. So just to fill this out, basically you are balancing out the equation, then you're looking at what coefficient is associated with the compound that you're looking at. So the next one would be a 3 in front of the CaO, and then a 1 in front of the B2O3. And the last one would be a 3 in front of the CaF2 and a 2 in front of the BF3. This assignment is just meant to get you comfortable with making those comparisons. Mole ratios are the keys to comparing a reactant to a product in a stoichiometry process, and so that is why you guys have to just do this a little bit of practice. All right, hopefully that helps. Again, balance the equations and then just write out the numbers. Those are your mole ratios.